So we're going to talk about estimating derivatives from a table. So when we started our whole derivative discussion on Monday, okay, what did we start out doing? We did slopes, right? Like we did slopes. And so if we have a table of values and we want to approximate a derivative, remember a derivative is an instantaneous rate of change. Well, the only way to do that is to use an average rate of change to approximate. It will always say estimate or approximate the derivative, okay? And when it says that, we're going to choose ordered pairs from the table around the x value for the derivative. So basically, we're just doing slope. Okay. If this is on a free response question, they will expect to see what you plugged in and your answer. Okay, so you can't just put, it's called a naked solution. You can't just put a naked answer up there, all right? You got to show them what you did. So a derivative is just our instantaneous rate of change. If we don't have a function, we can't use a limit, so we've got to approximate using an average rate of change. So take a look at this first one. All right, so selected values of the continuous function h of t are shown. Estimate h prime at 6, okay? If you notice, is there a 6 in my table? No, but where would it fall? Between 5 and 7. So those are the 2 points that we're going to use, okay? So your work could look something like this. You could say that h prime at 6 is approximately 70 minus 45 over 7 minus 5. All right, and then we'd get our answer, which would be, what, 25 over 2. Now, if you notice, there are units involved in this one. If we look at our table, okay, so what would the units be for this slope or this derivative? What was on top, x or y? Y, so y units come first, so meters per second, okay? Same as doing your slope, y units on top, x units on the bottom, okay? And that's as hard as that gets, okay? It is just slope, average rate of change, which is nice, okay? Y'all try the next one. You could. Yeah, you could. Yeah, this will be on a non-calculator section, so they're good with just leaving it as a fraction. Yeah, and you don't have to reduce the fraction either. So if you were to get, let's say, 50 over 4, you could leave it. Yeah, which is nice. They don't want you to waste your time doing arithmetic. So. Oh, there it is. I was like, where's my example? What's different about this one? Yeah, they actually give me an ordered pair for -1, okay? If they do that, then I'm going to use the 2 ordered pairs that are closest to -1. If -1's there, I'm going to use it, okay? So instead of using -3 and -1, -1 and 0 are much closer together. Those are the 2 points I'm going to use, okay? So you always want to choose the ones that are closest together. You all right?
Yeah.
Did your pen die?
Yeah.
I hate
Yeah,
that.
it's your
Dang. That stinks. There's a big eraser in that. There's cap erasers in that box if you need one. Okay. Trying to help.
She's already done it.
Okay.
Can't put any more of that in there.
Okay. It's a cat with really long legs. Okay. And a big long neck. It's a carafe. For putting animals together. Alrighty, so notice this is a new notation I didn't show you the other day. Anytime they put a dy dx and they draw a bar at x equals, that just means evaluate the derivative at x equals -1. I figured you could figure that out. All right, but that's a new notation. When we get to integrals and some derivatives, you will see me use that notation. Okay, so again, we're going to say dy dx evaluated at x equals -1 is approximately, and then we're going to put in our values. So 0 minus 1 over 0 minus -1 will give me, -1 over 1 or -1. Okay. All right, do that last one, or the next one, sorry. All right, which 2 points are we going to use? 5 and 15. Okay. So we're looking for that instantaneous rate of change at t equals 10. So we would do 25 minus 18 over 15 minus 5, which would give us 7 over 10. What would be my units? Good, gallons per hour. Okay, so from a table, not terrible. It's just slope. Okay, just slope, which is nice, right? But now let's talk about estimating a derivative from a graph. Again, notice it's an estimation, okay? So it's not gonna be perfect, it's not gonna be ideal, all right? The only time we can do it perfect is if I have linear pieces, okay? Like we did in our warm-up. Linear pieces, we can for sure just count the slopes and we can get that for sure, okay? So if we have linear pieces, the derivative is just the slope. Right? Now, 9 times out of 10, you're not going to have a linear piece. All right? It's going to be a curve of some kind. And what we're going to do is we're going to use the slope of the tangent line. At x equal to whatever point they want me to find the derivative, okay? To do that, we're going to sketch the tangent line. We're going to pick 2 points off the line. And we're going to do the average rate of change. Okay. Because this is an approximation, there are going to be times where we may get different values, all right? On an, I almost said EOC, I was thinking about No, on an AP test, it would be when they would draw the tangent for you, you would be able to see the exact points they wanted you to use. You would not be responsible for sketching the line, okay? So the first one we're going to do, we're going to sketch the line, and I think you're going to see how there could be some variance in the answers that we would get, all right? Then there's another one where they give us the line. It's a little bit easier to do, okay? So saltwater rinses are helping the most in terms of pain management. So, yeah, which is weird. But I think just because it draws it, I don't know, that's weird. But anyway, so I have a whole thing of salt and a cup that I brought with me today to do my saltwater rinses. And I brought a jar of Tylenol because that's what I have. Yeah. So you girls got to make it. By the time I left here yesterday, I had to go teach dance. And like even my eyeball was throbbing. I hurt so bad. But I got home, did some saltwater rinses, and I felt better. Okay. Tonight we have Becca's birthday at my house. She requested Mexican buffet. So we're having tacos. We're having sheet pan fajitas. I made chicken taco soup. And then all the things that go with all that. You know, cheese dip, chips and salsa, all that. And then she asked for a strawberry dump cake for dessert, so not a traditional birthday cake. Because gluten-free cake is kind of, and I didn't have time to make it from scratch, so we had to do something different. So we'll see. If there's any left, I'll bring it tomorrow. Because I can't keep that in my house, or we will eat the whole thing. So, okay? All right, so let's look at a couple of these. My eye's about to twitch. Okay. So this one says to approximate P prime at 5 given the graph of P of X, okay? So we want to think about this point of tangency, all right, which would be kind of right here. And, you know, if you have a straight edge, this is a good time to use it. Let me see if I can find a line to use. That's not it. Mine doesn't have a line tool, I don't think. Yeah, there's straight edges in there. They're like actual straight edges in there, by the way. Little rulers. Okay, I'm like, there are little rulers in there, but okay. I don't have one, so I'm just going to have to guesstimate it out, right? All right, so I'm going to draw that to be my line, my tangent line. It's not perfect, but it is what it is. Oh, that's 80. You're right, I don't know that. I'm going to guess that it's 8. It was not Aiden.
Oh.
Thank you so much. It's so funny. It was not Aiden. Mrs. Hughes Mercado. Okay. A little different. Yeah, they don't look alike. Okay. Do what?
Did you say my own names?
Yes. I always do. Oh. I don't know. We just always do. Isn't that bizarre? Okay, anyway. All right, rock and roll. Okay, so let's take a look here at this one. So we're trying to estimate this, and this is what makes it a little bit hard, okay? So it's kind of, I feel like I've got a point right here, all right? And then like maybe I've got a point maybe right here. It's hard to tell, okay? Or maybe one right there. So you're just gonna have to kind of guess and see, all right? And we're gonna have to come up with what ordered pairs. So it looks like on the x-axis, everything is counted by 1. So that looks like the ordered pair 4. And over here, I'm counted by what? 1, 2, 3 thousands. So maybe 4, 2,000. Yours may be a little different. And 6, 4,000. Okay. So I think last year it looks like I drew 3, 1,000 and 8, 7,000. Okay, so just you're going to get close, okay? Now, we're going to do our average rate of change. So we would approximate P prime at 5 to be 4,000 minus 2,000 over 6 minus 4, which would give me 2,000 over 2 or 1,000. Okay, it didn't give me any units, so I'll just take it to be 1,000. So paying attention to the scale, all right. Like I said, if it's one where they want you to get it exactly, all right, in terms of an estimate, they will draw the tangent line for you, all right, so that you don't have to guesstimate, or it will be linear pieces, all right. Try that next one. Hardest part on this one's the scale. What are we counting by each time? Going up. We know the horizontal scale's 1. 2.5, is it? Yeah, it'd have to be 2.5 because I'm going, there's only 4. All right, so I'm counting by 2.5s. So that's interesting. All right, so we're definitely going to approximate. The first point I see is -2, and it goes up 2.5. Okay. The next point that they marked is kind of halfway between 0, it looks like, and 2.5. I might call that 2. Like, it's hard to really tell. All right. So that would be 0, -2 maybe, because it doesn't look like it's all the way down. All right. And then we would do our slope. So then the derivative we would approximate at x equal -1. All right, so we're just going around that spot. -2 minus 2.5 over 0 minus -2. That'd be what? 0.5 divided by 2, which would be 1/4.
It would be -4.5.
Oh, yeah, you're right. Sorry, -4.5 divided by 2. Yep, sorry. I just looked at it and went, wait a minute, that's not right. And then what does that give me?
2.25.
Yeah. Okay. All right, so question about tables and graphs. We're just doing slope today, which is nice. Okay. Now, your calculator has a built-in way to do derivatives, but we're not ready for that yet. So we're going to talk about how we still estimate it using the calculator. And we're going to do this whole average rate of change thing. All right, we're still going to do that, but I'm going to give you some helpful hints that will make these a little bit easier. Okay. We're going to actually put the function in y1. Okay. And then we're going to choose x values near the value x equals a. Okay. And let me give you an example of that. So let's say that we're talking about the derivative at x equals 1.5. Okay. I might choose 1.6 and 1.4. Okay, so I'm just going to get close. Those would be the values I would choose around it. Okay. Then we're going to use our function notation to actually just type in the slope formula because I've saved the equation in y equals. So I would do y1 of 1.6 minus y1 of 1.4 divided by 1.6 minus 1.4. So we're just going to type it in just like that, okay? And remember that we get y1 by doing alpha trace. Let me show you a couple of these. All right, so let's take a look. We want to approximate G prime at 1.2. So G prime at 1.2 is going to approximately be, let's think about what Y values we'd want to use. What would be some good ones? 1.3 and 1.1. So I'm going to do G of 1.3 minus G of 1.1 over 1.3 minus 1.1. If this were on a free response, that's what they'd want to see. It would be calculator active. We're going to put it on our calculator to do the rest. Okay, so they just want to see what you had put in on the calculator. Notice after I put the approximation and what I'm going to do, I can use equal because the answer I'm going to get is exactly what I'm putting in the calculator. Okay, so grab your calculator. And then in y equals, we're going to put the actual equation. So I'm going to clear what's there, which was x times the cosine of x. Be sure, what mode are we in always? Gradient mode always, okay? And then on the home screen, alpha y equals so that we get that fraction. Alpha trace, we're going to take y1 and in parentheses, we'll put 1.3. Okay, arrow over, minus alpha trace, y1, parenthesis 1.1, and then on the bottom, 1.3 minus 1.1, and it will give me my answer. Okay, so negative 0.756. All right, so that's just nice. It's just a nice way to approximate a derivative, okay, on the calculator, using that calculator function capability. Okay, all right, y'all try that last one. Flash. Sucks. All right, what x values did we use? There's lots of options. You may not have all used the same ones. All right, so negative 0.9 and negative 1.1 are perfectly acceptable. Okay, I think when I did it initially, I did negative 1.05, so I got even closer to negative 0.95. Like, you can do that too. Like, so you could choose anything. What did you get for your final answer, Gavin, when you did that? Negative 2. Okay, there we go. All right, terrible. Probably what you're going to see when you see one of these, if it's in multiple choice, where it's an approximation like this, is they will pick the wrong values within the rate of change. Okay, so they might ask, this might be one where you see 1, 2, and 3, which ones could give you an approximation. So that's how I typically see those. Okay. All right, so your lesson practice is a worksheet that has several different things on it. Just talking about tables and graphs. I pulled all of these from AP Classroom for you to look at. 3 is interesting. It's one that you might want to think about for a little bit. What it's asking you there is, so for how many values of C does the limit as x approaches C, which is our difference quotient, which is the tangent slope, equal the algebra slope? Okay, so there's a lot of words there, but that's what it's asking us. So worksheet 2.3. So basically what it's saying is this, okay? So how I want you to think about it. Let's say we've got a graph that looks something like that, okay? And what it wants to know is if I take the slope between the endpoints and I move it through my curve. I don't know if it's going to let me. No. Let me do this. Hold on. Okay. That's close. All right, let me rotate it a little bit. Okay. How many times would it equal would it be a tangent? Would it just touch one time? And so if we look, it would touch one time. There's a broom in the back. All right, so you're just going to basically think about if I slide that tangent, that secant line through, okay, between the endpoints, how many times would it touch just one spot on my graph? Okay, that's what that question's asking. It's weird, okay, but just to give you a hint of what it's asking. Okay, that's number 3 on that worksheet. All right, so your lesson practice is just worksheet 2.3, okay. Note, tomorrow we're going to cover 2.4, but you're going to have a quiz Tuesday because we're not here on Monday. All right, on to 1 through 3. So everything that we've covered the first part of this week, what we cover tomorrow will not be on the quiz. So it's all the stuff about approximating derivatives, instantaneous versus average rate of change, okay? I don't feel like it's a terrible quiz, but you need to be sure you've looked at the practice, okay, to be able to do it. Go ahead for me and let's do the wrap up on Google Classroom, and then I'm going to get together what I want us to do practicing the limit definition of derivative, okay?